Good evening, everyone, and welcome to the Real Science Exchange, the pubcast where leading scientists and industry professionals meet over a few drinks to discuss the latest ideas and trends in animal nutrition. Hi, I'm Scott Sorrell, one of your hosts here tonight at the Real Science Exchange. Tonight, we have the pleasure of bringing a little something for everyone when talking molds and mycotoxins in today's agriculture. Since molds are everywhere in the environment, we have the opportunity to impact the health and profitability of all animal species and many crops. Joining us at the pub tonight are two guests. The first, Dr. Duarte Diaz, was part of the Real Science Lecture Series back in April. He shared some of the research and mechanisms around mycotoxins. Duarte, welcome to the Real Science Exchange.
Hello, everybody. Happy to be here.
Yeah, it's great to have you here. So part of the fun we have here at the Exchange, Duarte, is sharing our favorite drinks. So what's in your glass tonight for our discussions?
Well, since I'm still on office hours, I will go with academic drink of choice, which is root beer.
Root beer. All right, very well. We'll
Not
let
very
you go
strong,
on
but it'll do the job.
All right, good. It is beer, so that's all right. All right, I see you brought a guest with you tonight. Want to welcome Dr. Whitlow, and thanks for joining us here tonight at the Real Science Exchange. Lon, can you give us a quick summary of your background and then share with us how you got to know Duarte?
I spent my career at North Carolina State University, primarily in extension. 90 to 100% of my time was spent in extension. And that's how I got interested in mycotoxins, is because we kept running into dairy herds that had problems that were unexplainable. They had good nutrition, they had good management, good veterinary care, and yet there was something missing. Something was a problem. And so we had a good program there at NC State University in mycotoxins. It was real strong in the poultry area. And those guys encouraged me to look at mycotoxins and the possibility that it might affect dairy cattle. So we started looking, and sure enough, we did positively correlate the level of mycotoxins to a loss in performance and problems on these dairy farms. So we started doing a little more research in that area, most of it being applied research. And then along came Duarte from Puerto Rico, and he was looking for a possibility of a degree program. And we were very happy to have him work along with us. And so that kind of got him going in this mycotoxin area.
Great. So we got the professor and the student tonight. That's awesome. All right. So you didn't tell us what's in your glass tonight.
I'm drinking some Puerto Rican rum on the rocks that Duarte provided. So it's a pleasure.
Very nice. Good job, Duarte. Our co-host for tonight's discussion is once again Dr. Clay Zimmerman. Clay, it's bittersweet to be back in our isolated boxes on this screen once again, since our last few episodes were recorded at the Tri-State Nutrition Conference. I really enjoyed being with real people, with real drinks in person. But since we're back in front of our screens again, tell us what's in your glass.
I'm going back to my old standard. I have a hard cider here tonight.
All right. Very well. So tonight I switched it up just a little bit, Clay. I'm drinking a beer. My son goes to,
wow.
Believe it or not, my son goes to Penn State at the Erie campus, and they've got a little brew pub nearby. And I typically stop there when I'm out there visiting him. And he brought home for me, he's back home for the summer, my favorite beer from there. It's called Blood Rain, REIGN. It's made with blood orange. So it's quite tasty. So cheers, everyone. Thanks for coming to the Real Science Exchange.
Cheers.
Tonight's pubcast stories are brought to you by Reassure Precision Release Choline. Reassure is the most researched encapsulated choline on the market today, consistently delivering results to your transition cows of higher peak milk, reduced metabolic disorders, and even in utero benefits to her calf, leading to growth and health improvements. Visit balchem.com to learn more.
Well, Duarte, during the webinar, you kind of started us off with a little bit of history. One of the things that intrigued me is that the Salem witch trials had an element related to mycotoxins, but you didn't explain that a lot. Would you mind kind of going into that for us?
Actually, that's a pretty interesting one. When I finished my PhD at NC State, I was trying to get an opportunity to go do a postdoctoral work in Europe. And we had lined up. Dr. Whitlow and I had talked to some colleagues in France, and everything was lined up, and it didn't work out. Last minute didn't work out because they changed the position or something. And at the last minute, a group out of Italy contacted us and said that they would be happy to host me as a postdoc over there. And the primary person in that group was Gianfranco Piva, who was the director of their nutrition program at a small school there in Piacenza. And he actually had a presentation that I always thought it was really unique. That he goes through history of major events, and he tries to find places where potentially consumption of seeds with mycotoxins based on the symptoms and the type of diets they were eating could have been associated with mycotoxins. And I mean, he has about an hour long presentation where he dwells into some of these topics. And again, some of them are purely hypothetical, but some of them have actually some substantial information. And again, if you think about the ergot alkaloids and some of the behavioral issues associated, especially the hallucinations, then those would match very well with the symptoms seen at that time, but also with the type of diets that were predominant in that period. So there has been a couple of studies that I've looked at, potentially, what could have been the associated risk, and mostly is associated with ergot alkaloids and those types of behavioral issues. I mean, I really think it's pretty harsh to get burned on a stake for eating some granola and some grain, but I mean, based on that symptomology, you could potentially see an issue like that. And I remember, you guys remember a TV show used to be called House MD?
Oh yeah.
It was a diagnostic MD. I remember watching that show, and there was an episode where this lady comes in and she's hallucinating, right? And it's the only episode in that entire TV series where I actually knew what she had before the MDs in there. And obviously, it turns out that she was she would graze and pick fruits and seeds from the forest near where she was. And she was actually eating some grains that were high in ergot alkaloids. So there's even more modern take on that as a TV show in the 2000s, I guess it's what it was.
Yeah, very interesting.
Probably one of the worst examples of this in history was during World War II. And at that period of time, there was certainly a scarcity of food in Europe. And farmers couldn't very well get in the field and do much. And so they left a lot of the grains in the field to overwinter. And then people went into those fields during the winter or the next spring and harvested that grain. And the grain was contaminated with T2 toxin. And this has caused many people to die. It was a very severe problem. And along that same line, another interesting story associated with mycotoxins in history is in the early part of World War II, Russia depended upon horses for their cavalry to pull the equipment in the field, and a lot of their horses were dying, and so they asked a person to investigate this, and he did. He went into the field and discovered that the hay and straw that was being used for those horses was contaminated with mold and mycotoxins. And that person was Khrushchev, and it contributed to his escalation, in the party.
Interesting. When did we first discover mycotoxins? specifically maybe in animals?
I think, as described, we usually use a historical turkey X disease in the UK as the first event. Compounds were isolated and described. But again, you can also look back at periods of the discovery of penicillin in similar fashion. Again, just the compound used for two different reasons. But the turkey X disease, what year was it? I gotta remember now.
It's early 60s, 1962, somewhere in there. Yeah. We could even go back in the 1800s. People knew that moldy feed was bad for animals. They didn't know that mycotoxins per se were the cause of that, but they knew. We'd known that moldy feed was not good for a long, long time.
Yeah, so there's those two important inflections when the discovery of the compound started to become the norm, right after that 60s discovery of aflatoxin associated with Aspergillus flavus, and hence the name. And again, if you really look at the literature since then, the list of discovered mycotoxin is exponentially grown.
Yeah.
If you look for them, you'll find them. I still tell people the best way not to have mycotoxins is not to test for them. So, and I got that from Dr. Whitlow. So.
Pharmacologists look for all kinds of compounds produced by moles after the discovery of penicillin. So there were a lot of compounds discovered. They weren't necessarily associated with animal disease problems or health issues. But then, as Duarte says, after aflatoxin was discovered in the early 60s, we started discovering many other things like DON, for example, was discovered in the 70s. Zearalenone and T2 were isolated about the same time, and then just many more since that time.
So were the first issues in animals? Would that have been in poultry and swine?
That was that large turkey die-off. So there was actually animals dying off of a Brazilian nut meal. So yeah, it was chronic acute, pretty severe.
And so there was intensive research on that at the time, 1962, 63, and very quickly they showed that the aflatoxin was transferred into milk at about 1 or 2% of what's consumed goes into the milk.
Now, is aflatoxin the only toxin that we're concerned about making its way into a tissue or something consumed by humans?
I think in general terms, if we're looking at the traditional cuts of meats and byproducts of livestock industry, milk is the one potentially risk hazard, unless you start looking at things like liver. In societies or in populations where liver consumption is a high percentage of the diet, then that kind of breaks the rule, right? Because that's a potential area where there could be some concentration. But the animals do a pretty good job of metabolizing and mobilizing and excreting it. There's not a lot of storage of it. There is some speculation that ochratoxin stores a little bit better because it's been found in hams and other cuts of meat. But I think a lot of that is probably happening at the curing stages, and it's growing around it, and that's how it's getting contaminated, because it hasn't been replicated very well in animal models.
Now, I'm going to assume that most, if not all, of the contamination comes in through the feed. Is that correct?
Yeah, when I was in Italy doing my postdoc, we actually did some aerolized. It's still coming from the feed, right? But we did some aerolized research where we did emulsifications of the toxins and sprayed it up the cow's nose, and then looked at metabolites in the blood. We did it with aflatoxin because at the time, it was one that was very easy to do, but we did several other ones. After we figure out that cows don't like to get sprayed inside their nose and they'll just snot it right back out to you, we did find several toxins that we could actually identify in the blood flow, and I suspect. For human populations, like feed mill workers in areas where there's maybe not good sanitary practices or use of equipment, that could be a source of of exposure. I do know also that, for example, in Kenya, when the human populations are exposed to high concentrations, a lot of times is maybe there's a drought or there's a scarcity of grain, and so they usually dry them out in the ground. And in order to prevent people from stealing the corn, they would actually put it inside of their houses, like ground their house with that. And in those cases, those people are probably, a percentage of that high level of contamination that they're exposed to could be coming from an aerialized source. Dr. Whitlow can tell you a couple of stories about him showing up with a bloody nose if he wants to. I learned pretty quick, and I use my respirator almost all the time. But I have asthma. I developed asthma in grad school, and I've had it all along through. So I'm not sure it's mycotoxin related. It's actually large particles in the air related, where a lot of dust particles. But yeah, I think the other primary source would be inhalation. Those are the primary sources.
Yeah, farmer's lung is associated with breathing in mycotoxins from, again, moldy feed. So feed is the source, but it does get aerosolized, and we can breathe it in, and that can be toxic.
Are any of the feedstuffs more susceptible to molds and mycotoxins, whether it's feed, forage, dry forage, and siled forage? Do you have a feel for that?
I always actually answer that question in the context of I think, corn is a great substrate, but it's also a great substrate because we have a lot of it. So that it has a significant amount of influence in the occurrence of the toxin. It is a good substrate, but we grow an awful lot of corn. But again, if we compare corn to soybean, then you would see that here are two grains that are, these two are produced at similar quantities, right? One much more susceptible than the other. Again, a lot of the stuff that we did when I was at NC State with Dr. Whitlow was actually to look at forage sources as a potential contaminant and identify that they not only are often contaminated, but sometimes contaminated with a different array of toxins that we're not normally looking for or accounting in our system. So I think the substrate has a lot to do, but I also say molds and that produce toxins will grow in a building off of air particles, right? They're pretty adaptable. They're pretty they can find ways to enter in the system and be viable and produce the toxins. I don't know if I said it in the seminar, but there is a really cool study in Chernobyl after the Ukraine plant disaster.
Meltdown.
Yeah, when they went back in, the first thing that they actually saw thriving was this mold. And what they went and actually looked at the mold, and they found out that the mold had actually adapted to use radiation as a form of energy. And that mold today is in the lunar station or in the space station because of an example of a rapid adapting species. So they'll put it up there to see if it changes or adapted. And I want to say it's a fusarium, but it may be an aspergillus, but I can't remember. But it's actually one of those molds that we normally associate with toxins. So they find a way. They're pretty good at it.
I would say all feeds are susceptible to molds and to producing mycotoxins. But when I talk to dairy farmers, I tell them that silage is their biggest concern. And the reason for that is the silage does make up half of the diet. And you don't bring in new loads of silage. I mean, it's in the silo and you're going to feed that all year. And so if it is contaminated, it's a big issue. But with grain, you're going to get a new load next week or next month. The other thing is that we have some very unique mycotoxins that grow in silage that we do not see in grains. And I think that's important for the toxicity that we're seeing in cattle, particularly the penicillium-produced mycotoxins, which grow at a low pH and with only very little oxygen. And so they will grow in silage. And in many years, penicillium is the most prevalent mold in silage. And they produce some pretty toxic mycotoxins.
Now, is that throughout the silage line, or is that just in that crust along the top?
No, it's deep down. You'll get penicillium growing deep down in the silage because, again, it doesn't require a lot of oxygen to be produced. And as you go through that silo, you may hit some spots or layers where you see a kind of a bluish penicillium-like growth.
Mm-hmm. So are those toxins we typically test for, those penicilliums?
Not routinely. And I think we don't test for them because they don't occur as commonly in grain, and the ones that do occur in grain are not considered to be as severe. So a lot of the testing has been basically dictated by grain issues and by human issues.
Yeah, I think a lot of the analytical method discovery is driven by the commercial need. So, you see a lot more robust and a varied methodology for analysis for grain-based issues than you would see for silage. Even though silage is a large portion of the food chain in the dairy industry, it's not a large percentage of the samples most labs receive on a general basis. So there's a little less interest. To be honest, there isn't even an AOAC validated method for mycotoxin analysis in silage. There is people that have done self-validated methods in their labs. Some of the labs that specialize have actually gone and do that. But there isn't even at that extent a validated method for that. So we're a little behind the curve on that, but it's mostly driven by the commercial need and by the financial contribution in that aspect.
And that again is a reason why I recommend to dairy producers when they're analyzing for silage to actually determine the type of mold that's present in the silage. And this will give you some indication if the mycotoxins produced by that mold could be present. That is then related to the symptoms you see in the cow may give you a little better idea on how to move forward.
So is it possible to have mold and yet not have mycotoxins?
Yeah,
certainly.
It's quite
Absolutely.
common.
Yeah. Oh.
There's probably more than half of the molds that do not produce any toxins. It's like mushrooms. Some of them are fine. They don't produce any toxin. Others are toxigenic, meaning they produce toxins, and they produce an array of toxins.
Yeah, I mean, we talked about that a little bit. It's their function as a decomposition of organic matter. They play a vital role, and as soon as you harvest that plant, they're part of that ecology. So there's all sorts of them. Some of them will be beneficial, others will be damaging. I mean, again, even if you look at the human microbiota, there's some populations there that are beneficial.
On the flip side of that, can you look at a feed sample and visibly tell if there will be mycotoxin issues?
No.
I mean, I think long gone are the days where you can blue light corn and speculate that it had, and that's been disproven even at that level. I think any good risk assessment model is a combination of things. I think in a perfect world you'd be always testing, but I think in a general consensus, if you have a quick decision to be made and you have a certain amount of money that you're expending on maybe improving that situation, then you have to make decisions based on that. And sometimes, taking a leap of faith and saying that feed does not look good, right? And I have the options of not continuing feeding it, or maybe not. I don't have that option. Then let's start doing other things that might be proactive as much as reactive in that context. So I think a lot of people visually inspect feeds and make decisions. It happens almost every day. I can tell you, the vast majority of the phone calls I get are on the opposite spectrum. I sent a moldy feed to a lab it came back with nothing. And that's the most shocking phone call that I get on a consistent basis. And I said, look, if the molds were growing there, they're happy. They're unlikely producing mycotoxins. When they get stressed that they probably produced them, or they were produced in the field prior to harvest. So it's a really bad tool for diagnostic in the purest sense. But in essence, you do know that if that feed is moldy, there's probably something happened to it, right? It's not what you wanted to feed. So it drives the decisions still in the right direction, I would say.
Yeah, I would say it's a good thing to look at. And even though you test a moldy feed and it comes back with nothing, you have to remember there are hundreds of mycotoxins and you didn't test for all of them. So if you do have problems in the animals and you look at the feed and it's moldy, then I would certainly test it. It's an indication that it could be the issue.
Yeah,
so what
those two types of people with mold, like those that will see their bread and see a patch of mold and just cut around it and still eat it. Those that would see some mold in that bread and throw out the entire bread, right?
Yeah,
and
that's me.
That's perspective. I mean, if you really look at how far that mold has penetrated, it's probably better off to throw the entire bread. But in my household, my mom would have never thrown the whole bread away. The molds are far out, right?
Penicillin's good for you.
Yeah. Hopefully it's not harmful molds in there.
Yeah. So where in the process are we getting most of the mycotoxins? Is it happening in the field? You mentioned before, Duarte, it could have happened in the field, or does that happen during the harvest, storage,
yeah, I think
feeding?
That's changing. I think one of the things that we have to really be cognizant is as this climate evolution of the last 10, 15 years occurs, it actually has changed some of the environmental conditions in some areas where there's significant amount of production of commodities that are used for livestock feed production. I think it was like a month ago, there was a paper published out of environmental research letters from Felicia Wu. She used to be at Pittsburgh. I don't know if you remember Dr. Whitlow. She's now at Michigan State University. And she modeled these 20 different or 16 different scenarios of climate change. And she's actually predicting that the Midwest will have aflatoxin issues. And I think the time period they use is 2030 to 2041, right? An 11 period in the future, because the temperatures will keep on and creeping up, and that would allow more favorable environment for Aspergillus flavors. But when I started with Dr. Whitlow, we used to classify mycotoxins as feed toxins and field toxins, storage toxins and field toxins. And, one of the things that was really interesting when I got to Arizona is that about 90% of our aflatoxin contamination occurs in the field. With very little that's occurring post that. And it's because it's so hot in here that they're creating those microabrasions in the kernel, and it's allowing the aspergillus to propagate and penetrate in that seed. But we've taken molds that we historically considered mostly a storage problems, and now they're being found in very commonly in field contaminations. And I think that's a credit to the capacity of the molds to adapt and evolve and adjust. So yeah, it has been changing. I think, again, when I run risk assessment based on two primary criteria. First, if a feedstuff is occurring in a high percentage in that diet. The case of what Dr. Whitlow mentioned about corn silage for dairy, or let's say corn in general for monogastric diets. And then I look at other ingredients and I rank them based on risk, right? Is this a material that historically has been contaminated or has been more frequently contaminated? And I classify them based on that strata. But you have to be on your toes, because it changes a lot faster than you think it would.
Now, aside from mycotoxins, are there any other problems that molds cause in feeds?
Well, molds, when they grow in feed, they're going to utilize some of the nutrients that are present. So the feed is going to have less nutritional value than the original feed. And in some cases, like with proteins, the moles may use some individual amino acids more than others, so it will change the amino acid profile. But yeah, I'd say basically just lower nutritional value of the feed itself.
Mm-hmm. Yeah, and I think, in grains, it also, they've looked at energy concentrations. It also had, some significant changes in fat content, for example. So depending on what kind of mold you have, what priority they have as a substrate. The other side of that could be first that they may offer an off flavor that we don't know about, right? It's kind of interesting in some of the work that I did at NC State. We had the control cows trying to get on top of the feed to get the toxin contaminated feed, where apparently that one was tastier. And again, we have plenty of foods that we can use as example that moldy stuff is it's tastier, right? Blue cheese is a perfect example of that. Although I don't like blue cheese, that's outside of the scope, right? But I think the other side is that most can also be potentially, damaging too, like aspergillosis or several other types of mold inflicted diseases that are respiratory in nature. And again, in a system where maybe you are in a fine, very critical line between, proper respiratory health, introducing a moldy feed into that, pig unit or different facilities can be very problematic, because that mold could actually get into the lungs of the animals and cause a lot of issues.
Mm-hmm. So we all have heard of, kind of the standards, the aflatoxin, the DON, the zearalenone, and Lon, I think when you and I were traveling around California a few years back, we were talking about gliotoxin at that time, which I think was relatively new. I'm just kind of curious if there's any new and emerging toxins that we're finding out about, that we're just learning about.
I would say that there's always new emerging toxins. I don't go to the mycotoxin meetings with regularity because of two primary reasons. First of all, because half of the meetings are usually focused on analytical methods, and I'm not that greatly concerned about analytical methods. I think we do a perfectly good job. I wish we spent half of that time developing sampling protocols to reduce the sampling error, as opposed to getting better analytical methods. But the other half of those meetings are in these discoveries of these new compounds. And, time has told us that, since we discovered fumonisin, there's been a lot of other mycotoxins that have been discovered, but none of them have really made it to levels of concern outside of specific substrates or nutrients. There is a good, 5 or 6 new toxins that come in every 5 or 6 years. And, some of them we do analyze and we pay attention. But if you actually look at the overall literature of toxicologically based research, we're still doing 95% of the research on aflatoxin, DON, T2 toxins, zearalenone, and fumonisin. So that tells you a little bit. I think you definitely don't want to take your foot off the pedal, right? That's how fumonisin came about, right? It wasn't in the list, and it was an emerging toxin that actually ended up having a lot of issues, not only in the animal side, but also in the human health side. So it became the newest emerging toxins. But I get questions all the time, and I try to tell them I'm having a hard time with the 5s that I focus on, get along all the ones that get discovered. I usually start getting excited when I start seeing some survey papers that are saying it occurs with more high frequency. We obviously have our list of 5 or 6 ones that we wish everybody else was talking about. And again, Dr. Whitlow mentioned a good chunk of those are those that are associated with silage. I think we don't do enough on ochratoxin personally. I think it's a pretty important mycotoxin. And then some of those penicillium mycotoxins that are probably pretty frequently out there that we don't do enough with.
There's another aspect of that, and that is that Research has shown that when you have one mycotoxin in a feed, you probably have about 25 different mycotoxins if you were to analyze for many. And they do interact, they do synergize with each other and contribute to increased toxicity. But we don't really understand all of that. We're not really able to offer up exactly how that occurs and how severe it is. But we do know that some of these more obscure or minor mycotoxins do contribute to the overall toxicity.
Yeah, and experimentally, what you see is they'll put that in a really in a study to try to demonstrate the toxicity, and ends up being a pretty high concentration. And again, I think the complexity, we went through that even through my master's and PhD work, right, where we want to look at a diet that's similar to what the animals are consuming, but if you have 4 toxins in there, can you actually characterize what the toxicity is of the individual components of that? So it creates a complex experimental model when what you're actually trying to mimic is what's happening in nature, right, at the farm.
Mm-hmm. So let's say you had, sorry, Clay, go ahead.
Duarte, you mentioned a few minutes ago, about issues with sampling for mycotoxins, and you talked about that some during the Real Science lecture as well. How should these samples be handled when they're submitted to a lab?
Collected or handled?
Handled.
Or both. Okay.
During shipment.
It kind of depends. If you're actually just going for mycotoxins, you want to refrigerate them and try to stabilize them. If you want to get mold spores and mold counts, then you have to be a little bit more careful about how severe the environmental control is. But definitely not in the dash of the truck for 6 hours before you send it to UPS. I think you want to try to stabilize it as much as you can. I think Clay, I have more problems with how bad the samples are collected than how they are handled for the most part, because even if you have protocols, people just don't want to spend the time to collect the right sample. And I mean, it's basic human nature, but mycotoxin analyses are not cheap. I mean, they've actually gotten more expensive than they were before. I mean, it's more expensive now to analyze for mycotoxins than it was probably 30, 40 years ago. And if you're not going to collect the right sample, it just, I mean, that's a really, it's something that I struggle with. I mean, I go to a lot of meetings and I hear people arguing about HPLC is not good enough. We need to GC, mass spec, do this. And I'm like, if you're collecting I was going to say a bad word. So if you're collecting a bad sample, what does it matter if you got a $500,000 piece of equipment behind your analytical capability? I'd rather you do ELISA and take 20 samples or take one good sample than to do, one bad sample with a GC mass spec. So, I tell people all the time, go to a specialized lab, ask them how to collect the sample, and ask them how to ship the sample. And if it's a lab that knows how to do mycotoxin analysis, they will have a document they will send to you that says, collect sample like this, try to get as many places in that, mix it, do this, and then stabilize the sample before shipment. I mean, you could also dry the sample, if you want to truly stabilize it, right?
Yeah.
So what's a good mycotoxin testing program look like? Should all farms be testing for mycotoxins? Should they be testing all feedstuffs? Should they be testing throughout the year? What does it look like? What's your recommendations?
I try to recommend building a risk assessment model before you get to that point, because it's going to be very different in Florida than it's going to be in Arizona. It's going to be in Wisconsin or in California. So based on a general risk assessment model, you're going to take into account the commodities that you have and where they're coming from. And then you're also going to take into consideration what Dr. Whitlow talked about is how much of your total diet does that ingredient contribute. And then a combination of those data points will allow you to say, let's take a sample every time we open a silo and every time we're 3 months into it and at the end, right? At the critical points or whatever those are decided in the system. And the same for a large batch of corn coming. That's a good time to actually get a broad sample and see what's being brought into the system. Again, in Arizona, we spent a lot of time talking about cottonseed. I mean, I get in trouble all the time, but I don't like seeing cottonseed in Arizona dairy operations because it's incredibly risky to get a tank load of milk getting rejected for a commodity that, yeah, it's a great feedstuff, but you don't have to have it, right? So I base those on those points. I have never been a really huge fan of TMR testing because it puts me in the position where I still have to figure out which one of the ingredients is the one that's contaminated.
Yeah.
But I also understand the value, right? If you're doing a protocol based on, every time we have major changes, is that maybe you can do a TMR and then go back to the traditional individual ingredients. But that's usually how I try to address it on a regional or individual basis.
Mm-hmm.
I agree with Duarte about the risk assessment. I think for most producers, they evaluate the animals, their records. They look to see if production has changed. Has there been any change in health condition of the animals, any spike in any change at all that's detrimental there. Also, just evaluating feeds by visual observation and looking at it for the quality. I mean, it doesn't tell you if the mycotoxin's present or not, but it gives you some indication if that could be a part of the problem. So evaluating the herd first, that risk assessment is probably the first way to go. I don't normally recommend that every producer analyze on any kind of a routine basis, but rather evaluate their own situation and then develop a plan from there. I think Duarte is absolutely correct.
Yep, makes sense. So let's say you've tested some forages or grain, you've got a mycotoxin problem. Now what? Do you feed that feed stuffs? Do you discard it? Is dilution the solution? Where do we go from here?
Well, there's a number of steps, and I'll probably leave some of them out. I won't remember everything, but it depends on the level of toxin that you've got in the feed. Certainly want to keep any kind of contaminated feed away from the dry cows. And if you're feeding calves are going to be more susceptible. Dry cows will be more susceptible. So you may be able to shift the feed around. If you're grouping cows, shift it around so that the animals that are most susceptible receive the cleanest feed. And I tell dairymen that because very few people are going to throw feed away, right? They're going to try to use it some way, somehow. So that's the first thing. And then dilution is the next thing to look at. You've got to be a little bit careful about dilution because once you dilute the feed, the mold can continue to grow and produce mycotoxins. So you may end up back where you started. You need to look at management of your feedstuffs. For example, do you take silage out of the silo and stack it somewhere for 2 or 3 days before you feed the cows? You could be getting a mycotoxin growth or production in that pile. Look at things like treating the silo face with some organic acids to reduce mold growth, at least on that feeding surface. And then those organic acids will go into the TMR when you feed it and help keep the TMR stable. And of course, if you find it in grains, then you might then go to your supplier and talk about replacing a contaminated feed because it's really illegal to be selling a moldy contaminated feed. Mm-hmm. So you might get that feed replaced, and then certainly that would help on future deliveries to keep your feeds clean. I probably missed some things, but Duarte will fill in. And
I'll add up a couple ones. The first one being that dilution can also be tricky in the context of aflatoxin because there's some very specific guidelines that don't allow you to dilute the feed once it's over the legal allowed limit. So that has to be done within the context of understanding what the law and what the requirement is. For the other mycotoxins, it's a perfectly sound idea, but you also have to think about, for example, if you get a toxin like zearalenone, where zearalenone can be more problematic depending on the period of the reproductive cycle of the animal. If you dilute zearalenone, now you're going to have potentially more time points where animals are going to be at the right part of that reproductive cycle to have issues. So, I wish it would be super straightforward, but you have to consider that depending on the toxin, what kind of strategy. I also remember one that the Dr. Whitlow told me very early on that it didn't make sense initially, but as he explained it, it made a perfect sense, which is, you may actually have to feed more of that silage. Sometimes we are not moving enough of the silage phase in that silage, and then all that exposure to oxygen is actually what's triggering a lot. So if you actually went and bumped up silage intake into that diet, or amount to that diet, then you're now actually going to the recommended guidelines of moving the silage phase and while minimizing the amount of oxygen exposure and growth. And then at the end of that exercise is where we start looking at, can we feed the animals additives or products that may have beneficial impacts on that animal health. Like obviously anything that could potentially damage intestinal integrity, it could be very well remediated by products that have intestinal health as a mode of action, or obviously the traditional binders that we've studied over the years, where the objective is to find a compound that attracts to and binds to the toxin and reduces the absorption throughout the GI tract. But there's other things, for example, I've used antioxidants pretty regularly on poor quality silages, because I think apart from the mycotoxins in those poor quality silages, you also have free radicals that are being formed from the oxidation of the fats in that material, and also could happen in many of the other ingredients that we have, high energy ingredients that we have. So that's where you start thinking about strategically, what can I include into this diet to maybe help these animals cope or pass through this period. Again, all of those are proactive. At the same time, I think you actually have to be looking at what is the cost, so that you can potentially prevent it from happening in the future, right? So if the cost was a corn grain that came from Farm X, then you need to have that conversation, because next year you don't want to do that. Or if it's corn silage that came from your own facility, you may want to look at, that you harvest at the right time, at the right moisture, did you compact correctly, did I use a good inoculant, all those things. So you want to do your action activity. At the same time, you want to reserve some time to make sure that you correct the errors that led to that problem moving forward.
Now, if you're a nutritionist and you're looking at how do I change my ration formulations because I have mycotoxins, then, as Duarte says, adding some of these products that help prevent toxicity is certainly important. The other thing is, we talked earlier that mold growth itself reduces the nutritional value of the feed, so we may want to increase the nutrient levels to somewhat. We know that some mycotoxins reduce protein synthesis, and it's been shown that DON, for example, is associated with less microbial protein production in the rumen, so we may want to increase the protein level in the diet for that reason. Then antioxidant nutrients can be very important. Things like selenium, vitamin E, zinc, manganese, these are all antioxidant nutrients. And then there are other commercial provided antioxidant nutrients that can be used. So those are a few things. I think I'd like to emphasize that we need to try to maintain a robust rumen fermentation, because the dairy cow is going to destroy a lot of mycotoxins in the rumen. Now, if we cause acidosis and shut down the rumen, then we're going to have a lot more toxicity. So we want to maintain a good rumen fermentation. That may mean adding buffers to the diet, certainly maintaining good fiber levels, but definitely not pushing our cows too hard to try to increase milk production. We've seen this before. I've seen it a lot of times, is that a dairy farm sees a loss in milk production. And so they think, well, my diet, my ration's just not hot enough. I need more energy in that diet. So they push more energy. And before long, they're causing acidosis. And if this is a mycotoxin problem, then their problem just gets worse and worse.
So, Lon, you mentioned a few minutes ago about keeping contaminated feed away from the dry cows.
Yeah.
So I think I've asked you this question in the past, but I was asked this question again last week. So I get this question a few times every year, where a herd will run into an issue where either the heifers that are calving in for the first time or mature cows, they're not producing colostrum. There's a lack of colostrogenesis in these cows. Is there any relationship between mycotoxicosis and the lack of colostrum production?
I'm not aware of any data that's really clear on that, but there is some data, and it's not, most of it's not in cattle, that would suggest that it is possible to reduce colostrum levels in milk with mycotoxins. I don't know if that, I have no idea if that would be a major issue, a major association with mycotoxins or not. But what we do know is that mycotoxin, one of the biggest effects of mycotoxins is reducing immunity, suppressing the immune system in the animal. And this is why I think that it's very important with dry cows, is that they're already going to be immune suppressed when they freshen. And if you add the mycotoxins on top of that, then they just don't have any chance of getting started when they freshen. So you got to keep clean feed in front of the dry cows, and then also the calves, because the calves don't have that functional rumen, which allows them to destroy mycotoxins. So some of these toxins we talk about, the cows just, don't bother cows too much, are really important for calves.
Mm-hmm. Yeah, I would add, Clay, that if you look at the overall data, again, this is not ruminant data, but the monogastric data, there's a ton of data that shows reduction in immunoglobulins in mycotoxin exposed animals, right? I mean, in general, Stearns is one of the go-to experimental observations, right? In a lot of these studies. So it would make sense that if, circulatory levels of immunoglobulins were low, it would affect the quantity in that colostrum offering. So that's fairly well documented in that. As you guys know, ruminant research has the challenge of having to need a lot of mycotoxin contaminated feed to be able to feed a handful of cows, and then having to explain the statistical geniuses of our societies that, it's not, I didn't have 50 cows, I just couldn't afford them. We extrapolate a lot of that from the monogastric research arena. The other thing I would say, though, Clay, is that right now when we having all these conversations about epigenetics, and again I'm involved in that because of the heat stress work that we do here. But I find those complementary. The same thing is if you're exposing that cow at a very critical time period, to some contaminated feed that is making her make adjustments to be able to function normally, that's going to potentially have an impact on not only her, but the quality and the productivity of that offspring. And that's one of the things we would like to do here is we would like to put together this heat stress, low mycotoxin heat stress combination model to see that you don't always need to have 120-degree temperatures, or you don't always need 7,000 parts per billion of specific mycotoxin. It's those life happens every day, right? And and those things combine very well to cause challenges in the system.
I want to circle back to something both of you guys mentioned earlier, and that's feed additives. And typically, producers, nutritionists, one of the first things they're going to reach for if they've got a mycotoxin problem is a mycotoxin binder. If we could have kind of a brief discussion around the types of mycotoxin binders, and we'll not use trade names, but we've got your clays, you've got your yeast cell walls. There's mycotoxins that products that denature them. I don't know if it's in vivo or in situ. I don't know where it happens, but maybe just kind of an overview of the different classes of mycotoxin binders, mode of action, positives and negatives. I know that's a big question, but
you want me to tackle that? Yeah, I mean, it's a really large category. I think if you look at the market and the size of the market, the first of all is you have to really understand that they are additives that you are feeding for different reasons that may be beneficial during a mycotoxicosis. Like we spoke before, supplementing with an antioxidant, increasing vitamin E. These things could actually also be beneficial in a mycotoxicosis, and they're not necessarily being sold or being utilized specifically as a mycotoxin solution. I think the term binder is a little bit of a disservice on the complexity of the discipline. I think Dr. Whitlow and I try to coin the sequestering agent because it didn't have a definition in the dictionary, and nobody could claim that we didn't bind per se, because you're not always binding. Sometimes it's attractions or fitting into a pore or getting, just reducing the exposure to the gastrointestinal tract, right? So I think the categories can be really broad, and once you start removing those that are compounds that offer benefit independent of exposure to mycotoxins, and then you have this category that is mycotoxin solutions, right? Where there you could have the category that is more compounds that are designed to reduce the absorption through the GI tract through some type of interaction, whether that's binding, whether that's pore size. You can even think about potentially feeding an antibody coated that would just destroy the capacity of it passing through the gastrointestinal tract. Then you start getting into categories of products that are different mode of actions, maybe compounds or enzymes that are breaking down the molecule or changing the molecule structure, and then potentially decreasing the toxicity of that compound. Those can be kind of tricky because you have to demonstrate that the compound that you changed it to is first less toxic, but also not going to reconvert back into the toxic compound. I think in most cases, the compound that we talked about, right, the aflatoxin, the zearalenone, the T2 toxin, is really not the toxic compound. It's usually converted in the liver into some epoxide that is actually what's truly the active. So we have to explore those. But the categories are broad, right? We have a lot of products that are either trying to interfere with absorption or trying to disrupt absorption through changing on the molecules. But what you end up seeing in the market is a lot of products that try to do several things at the same time. And I think although that is a really good strategy, because you have different mycotoxins and the capacity to potentially, let's say, absorb some of those are going to be more difficult depending on the structure. What happens is that we need to really understand what the minimum effective dose is of each individual compound before you make a mix of them. If I make myself clear, I'm saying that if you take 3 known products that work, but they work at 1 gram, and you feed all 3 of them at 0.5 gram, you now made a super product that doesn't work, right? Because you failed to meet the minimum effective dose of the individual components, right? And they're not complementing each other to become better. So I think that's where we are right now in the landscape. We have a lot of companies that are doing some innovative things, or they're trying to do some mixtures of combinations. But I still think we need a little bit more work on titrating out dosage, being better cognizant of what it needs. I think what I always try to tell people is, if you think about parts per billion or parts per million, right? It's a very, very small amount. You have to be able to put something in that diet that has an effect on that very small amount. Less of something is always not necessarily a good, right? I mean, you may need a little bit of a higher concentration of those. But I think that's where the current market is. I think there is some really innovative things that are coming out with, for example, enzymes that may potentially destruct or change that molecule. Again, they still need to prove that it's all happening at the GI tract, because the other challenge is that a lot of the toxins are absorbed passively through the GI tract, and it occurs quite quickly. So if your enzymatic reaction requires a pH of 3, by the time you get to a point where you have a pH of 3, you probably already absorbed a considerable amount of that. Those are the kind of things that I think are evolving in the discipline. But the binders have been really good. I mean, the binders have done a fairly good amount of work for a very long time, and they're still very, very much used around the world. Probably the primary mode of action worldwide is the traditional binding type of products.
Duarte did a good job of summarizing all of that. And what I might add is that in Europe, they have a process for approval of products. In the U.S., we have no system for approval of these products, and I think we need to move in that direction. One of the problems we have with approval is that aflatoxin, being a carcinogen, can't be allowed in feed, right? We do have action levels, which is different from a allowable level, let's say. And if you use a product against aflatoxin, you would have to show that it's completely eliminated, or you still have a carcinogen in the feed. So this becomes a difficult issue, but we need to work in the direction of trying to get a FDA approved process for approval of these products.
I went to a meeting once where Dr. Whitlow asked a USDA person what it would take, and I kid you not, the person said, not until I'm dead. Now I would say he is probably, I shouldn't say that. I mean, he was fairly old at that time. So I think it's probably a good time to maybe potentially start putting a little bit of pressure into the system. Brazil has regulatory limits, and they actually have a category also. The European Union has one. I think if they actually look back and what their intention was, right? The intention of not creating a category was to not permit people to sell products that were contaminated because there was a solution for it. But if they look back, what they actually did was nobody followed the rules, right? There was no option. So the option was to continue feeding these materials that were contaminated. In this paper that I was quoting, they actually said in the thing that, when material is over the legal allowed limit, in the United States, people destroy them. I spent a lot of time traveling. You guys spend a lot of time traveling. I speak with a lot of producers, a lot of millers. I don't see a lot of material being destroyed anywhere. Mm-hmm. And we know from incidence data that there's much more contamination than destruction. So I think it's time to go back and maybe explain to them that, it was a novel idea, but it didn't have the right effect. It didn't reduce people from feeding aflatoxin contaminated diet. It just created a black hole, right? Mm-hmm. I mean, and the same for the products. If the products don't have a category to exist, then I can sell you anything, right? And call it something else, as long as I'm not violating the rules
Flow agent.
of what it needs to be called that, I can do that. And the number of products that have changed their name just because the USDA said, well, you can't call it that. In the end, those products are still in the market, right? They didn't really change that. So again, let me reiterate, I'm not wishing anybody to be dead. I'm just saying those people are probably no longer in the USDA based on the cycle of employment. So it may be a good time. I think it will require a push from the private sector and an institution like AFIA, to actually, rebring this conversation. I was talking to some people recently. I recommended that they updated the CAS book. Remember when that was published, Dr. Whitlow? Remember the CAS handbook?
I don't remember the date.
But it's been.
I'm not sure. Last week.
Yeah, no, it's been a very, very long time since that book was published, and it was a pretty important, reference. It's a USDA led effort, right? So I think that would be this is probably as good time to revisit this conversation about generating categories for products that are and I think that would be a great service for the producers, because then they need to stop being research facilities, right? The producer needs to have a product that's been tested and it works, right? They're not in the business of doing research. So I hopefully that happened. I will tell you another side of that. I'll tell Dr. Whitlow, because I probably haven't told him that. I still haven't managed to train one single student that has stayed on the mycotoxin field. So I don't know if that is a credit to yours and my stubbornness, but most of them realize that it's tough out there for it, and then end up working in other areas. So that's another problem that we need to solve. We used to be, the U.S. used to be the leading research institutions in mycotoxin research. Right now, about 60 to 70%, I just checked, of the research being published on mycotoxin is coming out of China, South America, and Europe. We are definitely not on the leading front anymore on that.
Yeah, there's a real problem with research in all mycotoxins, and especially in ruminants. For a researcher in the university system, there is no money, and they have to have money, and they have to produce research and publications. So they're not going to work in the mycotoxin area, and especially in ruminants. And so we need to look at if this is a real issue for people. We need to look at ways to increase the funding to get the research done. It's real frustrating to get these questions about mycotoxins, that we've been looking at this for, well, as Duarte said, we really started in the early 60s. So we've been going on 60 years, and we're not conducting enough research to answer the questions that people in the field really have.
Yeah, I have a couple of colleagues that have attempted to do one mycotoxin study and then call me back and said, "Oh, don't send me anybody else. I'll never do that again." They're not only expensive. I mean, they're not expensive in the context of other research in ruminants, but they're tricky, right? I mean, you have to handle materials with a certain level of scrutiny. There's a lot of hoops that you have to jump through. We used to have a pretty reliable source of culture material, and that might not be available in the near future. And it's not like I would love to take those cultures and grow them myself and continue that work, but the scrutiny the university would put on me if I was actually culturing compounds that are on the list of biological weapons, and I fit at least 55 of their profiles. So it wouldn't be really easy for me to do that. So I think it gets challenging, and it's only gotten more challenging. We try to do 5 experiments. We put together this whole protocol on T2 toxin. There's a ton of missing information on T2 toxin, and we got letters from the Department of Defense that said that only certain people had authority to buy more than a certain amount of T2 toxin and we weren't one of them. So we moved to zearalenone. It is challenging. I do still think that there is a need, and I would like to see more people in academia get involved in this area of research. I think, we get some people that are curious, but at this point in the ruminant side, the only people who are working on that went at some point through Dr. Whitlow's lab, So, when I was a student, Georgia was a big group. Minnesota had a group. University of Guelph had a group. But, Texas A&M had their group out there. And, Missouri, right now, a lot of those guys are retired, and there hasn't been a new batch of people interested in doing it. I mean, and I don't blame them for the same reason Dr. Whitlow said. There's not a lot of USDA grants out there for mycotoxins.
I don't know if you guys noticed, but Clay finished his Angry Orchard a few minutes ago, which is my signal. So since it is last call, I'd like to have you guys sum it up by just giving us an idea of whether you're a producer or a nutritionist. What are some things that you can do to reduce mycotoxins on the dairy farm?
Tonight's Pubcast toast is brought to you by NitroSure Precision Release Nitrogen. Maximize rumen microflora with the consistent release of NitroSure to turn up the dial on rumen efficiency and productivity. Visit balchem.com to learn more.
And Clay, let's start with you.
Well, I want to start off first by saying that this has been a real pleasure for me. I don't get a chance to interact a lot with some fellow NC State Wolfpackers, so it's been a treat for me. Dr. Whitlow and I go way back. He served on both my master's and my PhD committee. And Lon, I have a story I want to tell about you. So back in the when did you start on faculty at NC State? 1979?
That's right.
So Dr. Whitlow is the hotshot new dairy nutrition extension specialist in North Carolina. So he's introduced by his by the chair of the dairy extension department at a large meeting. He said, "I'd like to welcome our new dairy nutrition extension specialist, Dr. Ron Winslow." Oh,
that's a way to start.
That's right. Right. So no, I've really enjoyed this discussion this evening. So yeah, lots of key takeaways here, but obviously a lot of challenges here too, as have been discussed here, that the occurrence of mycotoxicosis, it seems to be increasing. Some of that related to the changes in climate, as Duarte discussed both in the Real Science lecture and this afternoon. And so the issue is not going away. And I actually really enjoyed the discussion at the end about the need for USDA to take a look at trying to legitimize some solutions here for the industry.
All right, Lon.
For a dairy farmer, I think they need to really emphasize cropping management. They need to start by looking at getting crops planted at the right time and harvested as early as possible to fit in their area, to fit the best season for growing that crop, so that it's not stressed. Also, rotating crops. We know that having continuous corn is going to create more problems with mold. Even corn following small grain is a problem, because it's the same mold in small grain and corn. So we need to rotate with some legumes if possible. And then once you harvest that crop, follow the best management practices for silage making, mainly to get it put in the silo quickly at the right moisture content, and get it packed well so you eliminate oxygen. And then when you are feeding that silage, that needs to be fed well so that you feed a foot a day off of the silo surface, and try to avoid again oxygen infiltration into the silage mass. And then the next thing would be to look at the herd and the feeds themselves to try to evaluate whether or not a mold could be a problem, and if it is, to do some testing, and then follow some of the best practices on trying to eliminate that mold or add products to the diet to eliminate the toxicity as best as possible.
Thank you, Dr. Whitlow. Duarte, give you the final word.
Okay, well, I am actually going to say a couple of stories too. You know, I'll tell you, when I was a senior undergraduate student at Jacksonville University, I came up to North Carolina to visit with potential faculty, and I met a lot of people at that time, and it was the amino acid era, so everybody was working on amino acids. And I think at the end of the day, my last meeting was with Dr. Whitlow and Dr. Hopkins, because they both had very high extension appointments. They shared graduate students, and we got into the room, and Dr. Hopkins started to talk about amino acid nutrition. And I think Dr. Whitlow saw my eyes kind of, glaze or something, because he quickly interrupted and started talking about this project that he had thought about working with clays. And for those that don't know, I don't have an ag background. I didn't grow up in a farm. I didn't know hardly anything about farming until I came to NC State. But I had been curious about the macaws and the parrots in the Amazon and how they would eat clay to detoxify, bad seed quality. And that was the link that started when Dr. Whitlow started talking about that. I didn't know what, a dairy feed stuff looked like. I didn't really know more than driving by a farm every once in a while in my life what even a dairy cow looked like. But that one conversation about clay triggered, my entire career. So, I don't know if I ever had a chance to say thank you to Dr. Whitlow for interrupting that day, because I was ready to go to the food science department and work on vitamins, because I did not want to do amino acids like everybody else. But another story is that shortly after that, right before I moved to North Carolina, I asked Dr. Whitlow, you know what, I'm a kid from the tropics, from the Caribbean. I really don't like cold weather. And he's like, man, it never gets cold in North Carolina. The weather is great. That November, we had probably one of the worst ice storms in the history of North Carolina. I was like, wow, this is a great way to start a relationship here, long-term relationship. The third one along those lines is we once tried to get OSHA to get us to pay for our respirators to go collect samples. And we sent a letter, and they wrote back saying, aflatoxin is not on a list of toxic compounds. So they didn't want to. So Dr. Whitlow said, go into the literature, get me a couple of papers of human exposure. And the first paper I get was of this lab in, I can't remember what university, where the graduate student had developed polyps in his lung from doing research with mycotoxins. So I was like, man, this is going to be great from here on. So we wrote a little document, and they finally approved the respirators for us. But that was the start of a very long career path, and I owe a lot to Dr. Whitlow for being patient with me, because it couldn't have been easier having somebody that was that green in his lab, especially considering how applied his work on. And on my closing statements, I think I would like to see more work on the identification of better biomarkers of exposure. I think if we are better able to identify exposure to toxins through animal tissues or animal samples, for being that urine or blood or any other sample, we would first eliminate this error associated with sample and collection. That would be out of the equation. We've eliminated that immediately. Second, we would have a really solid diagnostic tool, right? A guy calls you, I think I have a mycotoxicosis. You take a blood sample, take it to the lab, and you're able to say, yes, you do, right? But also, thirdly, from a research perspective, these products that are designed to alleviate toxicity could be very easily evaluated if we had consistent biomarkers. And I think we're getting there. We're slowly getting there where there's better and better biomarkers. But I would like to get to a point where those are not tough analytical procedures to be done with very high-end equipment, where we can actually do it on an on-farm or at a university lab level for research and diagnostics. So again, I want to thank Balchem for giving me the opportunity. I've actually never been in a thing like this, so now I feel like I'm important. So I thank you for the opportunity, and also the giving me the opportunity to talk to Dr. Whitlow again. Has been longer than it should be. So I appreciate you guys for facilitating that.
No, you're very welcome. I'm going to agree with Clay. This has been a real treat. I've enjoyed the stories. I've enjoyed the learning. It's an important subject, and I appreciate you guys breaking it down for us. It's a subject that's important for all species, and so I think it's going to be very interesting for our entire audience. So I want to thank you. I also want to thank our loyal listeners, right, for stopping by once again to spend some time with us here at the Real Science Exchange. I hope you had some fun. I hope you learned something. And hope to see you next time here at the Real Science Exchange, where it's always happy hour and you're always among friends.
We'd love to hear your comments or ideas for topics and guests. So please reach out via email to anh.marketing@balchem.com with any suggestions, and we'll work hard to add them to the schedule. Don't forget to leave a 5-star rating on your way out. You can request your Real Science Exchange t-shirt in just a few easy steps. Just like or subscribe to the Real Science Exchange and send us a screenshot along with your address and t-shirt size to anh.marketing@balchem.com. Balchem's Real Science Lecture Series of webinars continues with ruminant-focused topics on the first Tuesday of every month, monogastric-focused topics on the second Tuesday of each month, and quarterly topics for the companion animal segment. Visit balchem.com/realscience to see the latest schedule and to register for upcoming webinars.